In this video, I'm going to give you two examples of how to calculate a confidence interval for a proportion. Let's go ahead and work on problem number one. I'm going to use data from the General Social Survey from people who were surveyed in 2010 and 2012 and were asked if they voted in the 2008 elections. The proportion of people who voted is calculated using the General Social Survey to be equal to 0.749. That is 74.9% of people in the 2010-2012 General Social Survey claim to have voted in the 2008 election. We can calculate the people who did not vote as 1 minus this proportion, or 0.251. This is typically given as p hat, the number we're interested in, an estimate of the proportion of people who voted in 2008, and 1 minus p hat. Let's review our confidence interval. We know that a confidence interval, whether it's 95, 99, or 99.9, is equal to some statistic, in this case p hat, plus or minus some t statistic, which we look up in a t-table, times some standard error, which in this case is given as sigma hat sub p hat. Again, if we take a close look at that, we know that sigma hat means an estimate of a standard deviation or some type of variance, and the sub p hat tells us that it's an estimate of a proportion. This is our standard error. Our standard error, sigma hat sub p hat, is equal to the quantity of p hat times the quantity of 1 minus p hat divided by our sample size, and we take the square root. So we have to know how many people were surveyed in 2010 and 2012, and it turns out our sample size is equal to 3,407 individuals. The last thing we need to know is our t statistic. This is a very large sample, so I can go ahead and use the z-table or the t-table and look it up with 3,407 degrees of freedom. And if I'm going to calculate a 95% confidence interval, then my z or t statistic is going to be 1.96. So now we can go ahead and begin piecing together the numbers to calculate our lower limit and our upper limit. One last point I want to make, we can also calculate as part of this the margin of error, which we've discussed elsewhere, which is equal to our t statistic times our standard error. And in total, that's our margin of error. Let's go ahead and calculate our statistic. We'll just go right ahead and calculate our standard error based on this formula above. We'll plug in our p-value, which is 0.749, and 0.251, so there's our estimates of the proportions. And we'll divide this by our sample size, 3,407. We'll take the square root of that, and when we do these calculations, we get a standard error equal to 0.007428834, depending upon how your calculator or you decide to round this. Now we can go ahead and build our confidence interval. Our 95% confidence interval is going to be equal to 0.749 plus or minus 1.96 times 0.007428834. You see, I'm carrying all this precision as long as I can, and I'll round when I get to the end. My lower limit is going to be equal to 0.749 minus my margin of error, and that's the 1.96 times the 0.007, which I've gone ahead and calculated as 0.014 4, 5, 5, 9, 5, 4, and so my lower limit is 0.7344. My upper limit is equal to 0.749, my p hat, plus 0.014555954, and that's equal to 0.7636. So now I can write that my 95% confidence interval extends from approximately 73.4% to approximately 76.4%. So looking at 2 years of the General Social Survey, 2010 and 2012, we have an estimate that approximately 74.9% of this sample claimed that they voted in the 2008 election, and we believe that the actual estimate with a 95% confidence interval lies somewhere between 73.4 and 76.4%. In this example, I again turn to the General Social Survey and look at data collected in the year 2012 when respondents were asked whether they had a gun in their home. We had approximately 34.35% responded that they had a gun in their home, and that 65.65% did not. So again, this is our p hat, and this is 1 minus p hat. Our sample size was equal to 1,281 individuals. And for this particular example, I'm going to calculate a 99% confidence interval. So my t statistic, using the t-table with 1,281 degrees of freedom, is 2.58. One of the things that's great about using the General Social Survey is typically our sample size is quite large, well over 125. So again, I tend to just to remember 1.96, 2.58, and 3.29 as my critical values for my t-statistics. Let's go ahead and calculate our standard error. We know that our standard error, sigma hat sub p hat, is going to be equal to p hat times 1 minus p hat over n, and we take the square root of that. And now I just plug in my numbers, 0.3435 times 0.6565 divided by 1,281, and we take square root of that, and I get a standard error equal to 0.0132682. I now need to calculate my margin of error, which is going to be 2.58, my t-statistic, times this standard error. And I can write out my entire formula as follows. I'm going to have a confidence interval equal to 0.3435 plus or minus 2.58 times 0.0132682. And again, I can go ahead and calculate my upper and lower limits, and I end up with a confidence interval equal to the following. That is to say, my best estimate based on 2012 data is that approximately 34% of the population has a gun in their home, and I'm 95% confident that that estimate is captured in the range of 31 to 38%. Notice that this standard error in this range of values is greater than the problem before, but we have a much smaller sample size.